Welcome to Delivering High Quality Core Instruction. My name is Jenna Richard, and this content was developed by the Rhode Island Intensive Math Intervention Project with support from project consultants. When thinking about effective instruction, the following instructional supports should be evident to promote equity and ensure our students are ready for college and career. Universal design for learning, differentiation, scaffold, and accommodations or modifications when appropriate. Let's first take a closer look at each of the instructional supports using mathematics examples. Then we will explore how each of those supports work together to create a mathematics classroom that is set up for success. Universal Design for Learning, or UDL, is an instructional framework that focuses on teaching learning processes in a way that will serve the needs of the greatest number of students in an educational setting, regardless of their learning characteristics or perceived abilities. Universal Design for Learning provides a blueprint for developing instructional goals, teaching methods, materials, and assessments that work for each student, not a single student, one-size-fits-all solution, but rather flexible approaches that can be customized and adjusted to meet individual needs. The purpose for designing curricula based on UDL principles is not simply to help students master specific content, but to help them become expert learners who know how to learn. Designing curricula using UDL removes potential barriers that could prevent learners from meeting important goals, while also helping them access and master subject area content. Many features of UDL are reviewed in Gateway 3 of Ed reports. If your district or local education agency is adopting new materials, you should be thinking about how those materials rate on Gateway 3. We'll now watch a video from CAST that discusses UDL in more depth. Think about connections to your curriculum or curricular materials as you watch.
This teacher needs to meet a curriculum goal, and she's got a very diverse group of students. And so does this teacher. And this one. Most do. In fact, research shows that the way people learn is as unique as their fingerprints. What does this mean for teachers of today? Classrooms are highly diverse, and curriculum needs to be designed from the start to meet this diversity. Universal Design for Learning is an approach to curriculum that minimizes barriers and maximizes learning for all students. Whoa, that's a fancy term. Universal Design for Learning. Let's unpack it a bit. Let's think about the word universal. By universal, we mean curriculum that can be used and understood by everyone. Each learner in a classroom brings her own background, strengths, needs, and interests. Curriculum should provide genuine learning opportunities for each and every student. Now let's think about the word learning. Learning is not one thing. Neuroscience tells us that our brains have three broad networks. One for recognition, the what of learning, one for skills and strategies, the how of learning, and one for caring and prioritizing, the why of learning. Students need to gain knowledge, skills, and enthusiasm for learning, and a curriculum needs to help them do all three. But every learner is unique, and one size does not fit all. So how do we make a curriculum that challenges and engages diverse learners? This is where the word design comes in. A universally designed building is planned to be flexible and to accommodate all kinds of users, with and without disabilities. It turns out that if you design for those in the margins, your building works better for everyone. Curb cuts and ramps are used by people in wheelchairs, people with strollers, and people on bikes. Captioning on TV serves people who are deaf, people learning English, people in gyms, and spouses who get to sleep at different times. UDL takes this idea and applies it to the design of flexible curriculum. UDL goes beyond access because we need to build in support and challenge. So how do we use the UDL framework to make learning goals, methods, materials, and assessments that work for everyone? First, ask yourself, what is my goal? What do I want my students to know, do, and care about? Then ask, what barriers in the classroom might interfere with my diverse students reaching these goals? To eliminate the barriers, use the 3 UDL principles to create flexible paths to learning so that each student can progress. Number 1, provide multiple means of representation. Present content and information in multiple media and provide varied supports. Use graphics and animation, highlight the critical features, activate background knowledge, and support vocabulary so that students can acquire the knowledge being taught. Number 2, provide multiple means of action and expression. Give students plenty of options for expressing what they know and provide models, feedback, and supports for their different levels of proficiency. Number 3, provide multiple means of engagement. What fires up one student won't fire up another. Give students choices to fuel their interests and autonomy. Help them risk mistakes and learn from them. If they love learning, they will persist through challenges. And remember, always keep in mind the learning goal. Get rid of barriers caused by the curriculum and keep the challenge where it belongs. And that's it. Okay, quick recap. Show the information in different ways. Allow your students to approach learning tasks and demonstrate what they know in different ways, and offer options that engage students and keep their interest. Universal design for learning equals learning opportunities for all. For more information on UDL, go to www.cast.org.
As you heard, there are 3 guiding principles in UDL: engagement, multiple means of representation, and action and expression. Let's explore each of these through a quick example. We're going to use the UDL guidelines that are available in the module resources as a model. Think about engagement, or the why of learning. You could provide to all students an instructional choice menu. You could facilitate peer-assisted learning, or implement a self-monitoring system to allow students to set learning goals and determine their success toward meeting those goals. When thinking about representation, the what of learning, you could provide different examples of base 10 representations to students. Additionally, you could implement a Freyer model to help teach new mathematics vocabularies and make connections to what students already know about a new topic. When thinking about action and expression, the how of learning, you could provide various modalities to access new content. For example, sequence guidance with access to manipulatives or whiteboards. Or you could allow students to select how they'll demonstrate what they know through a writing response, an oral presentation, an artistic approach such as a song or an illustration, or even coming up with their own mnemonic devices to remember what they've learned. You can provide additional structures to help students organize their learning. For example, structured Google Drive folders that automatically save content. It's also important to remember that as students demonstrate what they know, we should also ensure the alignment to the standard addressed in the lesson. For example, a writing objective and writing standard would not be measured by an illustration or oral presentation alone, but they can be in place to support a student toward meeting the ultimate goal of producing a writing sample. After planning instruction using Universal Design for Learning as a framework to ensure barriers to learning content are reduced, some students may need more help. This is where an educator will differentiate. What is differentiation? Differentiation means tailoring the content, process, product, or learning environment to meet individual or group needs. It does not mean modifying content. Differentiation still promotes a learning challenge that is accessible. These anchors of differentiation should sound familiar as they connect directly back to UDL principles. In fact, we may differentiate for individual students what we've already designed universally for all learners. To differentiate instruction for either academics or social behavior in our classrooms, we could consider the following: teaching pre-skills to an individual or group of students, increasing or decreasing our rate of introducing new skills, teaching terms and concepts, preparing anticipation guides, teaching using explicit instruction strategies, using advanced organizers or verbal prompts, giving options for task completion, differentiating seat work assignments and learning center activities, and ensuring an openness to create small groups within our classroom. Hopefully you're beginning to see the connections. Differentiation strategies allow us to tailor what we've already put in place through universal design for learning as a way to help us become more efficient and strategic with the supports we're providing. Let's explore this a bit more. Say you're implementing a self-monitoring system with your whole class, UDL, multiple means of engagement. All students set a goal for each mathematics period, monitor their performance, and discuss with a peer or with you what they might do differently or continue doing to ensure they meet their goals. What you know is that this strategy needs some differentiation for Jesus, your English language learner. He needs the text for goal setting in both English and Spanish, as well as visual cues. You also need to differentiate for Monica, your student who is diagnosed with attention deficit disorder and has an IEP. She needs more frequent monitoring checks than the other students, and you need to build in an additional goal area for her to monitor related to completing mathematics assignments independently using a checklist. And you also have a small tech-savvy group of students who use an app to monitor their progress rather than filling out a piece of paper. By integrating differentiated instruction into your UDL approaches, you've successfully supported all learners in your class while also meeting their individual needs. Let's now explore differentiation a bit more in depth. This content was developed in partnership with Dr. Mary Little at the University of Central Florida and Dr. Brad Witzel at Winthrop University in South Carolina. Let's move through the example on the slide. In a lesson designed to teach multi-digit subtraction, Mrs. Kim conducts a task analysis, breaking down what students need to do to complete the problem using a 5-step process. This will help her more accurately determine where in the process an individual or group of students may need differentiated supports. In this hypothetical setting, Mrs. Kim reviews student data that reveals her students understand place value and have decomposed numbers before. Therefore, her process should take advantage of these strengths. Multi-digit subtraction problems can be broken down by Step 1. Expanded the minuend and subtrahend for each place value. This decomposition shows the place value and sign of each digit. Step 2. Since students haven't learned how to subtract to equal a negative number yet, students must regroup to make each place value subtraction equate to a positive familiar number. Step 3. Subtraction is performed vertically per place value. Step 4. Each difference is connected to the total number of hundreds, tens, and ones. Step 5. The final answer is displayed. In the class, Mrs. Kim has been able to identify a group of students who experience some challenges with this type of problem. The students' areas of need are as follows. 2 students lack place value understanding. 1 student forgets to regroup. 2 students are weak at single-digit subtraction, and 2 students misalign or lose track of their subtraction per place value. Using a student's needs chart, Mrs. Kim aligns the student's needs with the concepts within this lesson. Let's look at how the student areas of need we learned about on our previous slide affect their work through each step within the multi-digit subtraction. Now that we have an understanding of the student need in the relationship to the skills necessary to solve the problem, differentiation strategies are then identified for each student's area of need so that every student can access the standard. The differentiation is then coded to show which are student dependent and which are highly teacher dependent. The red are teacher dependent, black are transitional, and green are student dependent. One way to further differentiate instruction across the tier is through scaffolding. Scaffolding instruction is important for all learners who may require temporary supports to help them master a task. Scaffolding instruction is another tool for us to use as we consider UDL and differentiation. Scaffolding within instruction can support students as they independently practice what they've learned, allowing them to develop independence and learn tasks and apply them across contexts. This connects to the concept of attention to transfer, meaning that students who learn a strategy, approach, or task in one setting or context can readily apply it in another. Scaffolding as a component of differentiated and/or explicit instruction can support student independence. It's also important to note that scaffolding is a temporary or adjustable set of supports designed to help students master content and perform more independently, like on a standardized summative assessment. There are several types of scaffolds that exist. There's task scaffolding, which means modeling and providing stepwise instructions where you're trying to fade the teacher guidance on that task. Mnemonics are a great way to get started as students can learn them and use them independently later on when they are solving problems or completing tasks with multi-steps. There is also material scaffolding, which includes cues, prompts, examples, or simply the material objects that you're using. Finally, there is content scaffolding, which is selecting the content that's right at the level for the student, using familiar and interesting content. We start with easy things that they're familiar with and build up slowly, bit by bit, to a more complex idea. Content scaffolding, however, is not the same as content simplification. We may start with simplifying content, but then we'll continue to scaffold until the learner is independent in a skill and making progress toward grade level standards. It's recommended to start with task or material scaffolding before content scaffolding to avoid any pitfalls related to providing students with grade level access. No matter the type of scaffolding used, the goal remains the same: student independent. We're going to walk through an example of how to scaffold instruction using a multiplication grid. While this particular example doesn't relate directly to the multi-digit subtraction problem presented earlier, the concept is the same. As previously mentioned, scaffolds should be temporary. We use scaffolding to help students develop independence. This is done through strategic fading of support, which we'll demonstrate next. Let's go through an example of scaffolding in mathematics. When teaching complex computation problems, how many of us have said, "I wish these students knew their math facts"? So what do? Well, oftentimes we just hand over a calculator. A concern with using calculators is that students can access every multiplication problem, including those that they've already been learned. They may become dependent on a calculator, looking up every calculation, even once they've mastered. This lack of confidence may interfere with competence and definitely will slow down the problem-solving process. So we suggest scaffolding instruction, not merely handing over a calculator. As such, we encourage a scaffolded multiplication grid. The use of the multiplication grid is to work with the fluency intervention. It is important to fade the utility of this grid so that the student relies more on what they have already known. Likewise, we should make it difficult for students to look up answers which they have already memorized. This example of a multiplication grid reveals all the multiplication answers from 1 to 10. So the student could look up 9 times 8 and match it up and say the answer is 72. To scaffold the multiplication grid, we assess what the students have already learned. Some of the first facts we teach our students are the multiplication of ones and tens. Once those facts are mastered, we remove them from the multiplication grid so that the student isn't tempted to just look at the grid to locate an answer to a multiplication problem like 2 times 10 that they have already mastered. The student will already know the answer is 20 without needing the visual cue on the grid. Now let's assume that the student has already mastered ones, tens, and fives. So to further scaffold, we also delete the 5 facts so that the student gains independence with the multiplication of fives. As the student learns additional multiplication facts, learning may become more spotty from fact to fact. Using this chart, the student should no longer be able to look up facts that they have already been mastered. So a student wants to look up 8 by 8. They look at the chart and see it's blank there. That makes them think of a mnemonic device they learned. Wait, he ate and he ate until he was sick on the floor. 8 times 8 is 64, right? In this case, a potential crutch for learned helplessness is gone. So we're pushing them to not only learn individual facts, but also to recall them later on. As the student gains independence, this chart becomes more and more bare until the student is completely independent. While this is only one of many ways to show scaffolding within mathematics, our goal is to show how scaffolds support a student's independence. Let's return to the multi-digit subtraction problem discussed earlier. One of the strategies we discussed for one of the students was scaffolding place value before beginning the lesson. Which type of scaffolding do you think would be most appropriate? Content, task, or materials? How would you scaffold using the type you selected? Take some time to stop and reflect. Jot down your ideas for scaffolding place value before beginning the lesson. Let's see if what you came up with is similar to what you just jotted down. For our example, we decided on scaffolding the task. We know that the numbers in the problem each contain hundreds, tens, and ones. So we might scaffold by first showing the student a completed model of what a number looks like by place value. Then we could provide a blank worksheet for them to use manipulatives to show each number in the subtraction problem. 325 and 148 in the same way. Writing out the number. For students with disabilities who are receiving specially designed instruction, we may need to provide even more support. Delivered by a special education teacher or related service provider identified on the student's IEP during core instruction or through intervention. As an example of what this support might look like, let's go back to the task scaffolding example we talked through on an earlier slide. So we've scaffolded by showing the student a completed model of what a number looks like by place value. Then we provided a blank worksheet for them to use manipulatives to show how each number in the subtraction problem, 325 and 148 in the same way, writing out the number by place value. From there, we could work with the student and have them write out the number in expanded notation. 325 is expanded to 300 plus 20 plus 5. Then we can have them write the next number in expanded notation and line up the column, hundreds, tens, and ones for each number in the subtraction problem. And then model how we would regroup, taking one 10 from the 20 that we have and adding that 10 to the 5 so we have 15 ones and can move forward with the subtraction. From there, we could either model using manipulatives or have them try the same process with the hundreds on their own. And finally, we would prompt them to complete the subtraction to arrive at the final answer, 177. Over time, as they begin to solidify their understanding, they should be able to generalize what they've learned, no longer needing the column headers to write numbers in expanded notation and accurately regrouping. Even when this level of support, a few students may need additional explicit instruction through the use of manipulatives, corrective feedback, and multiple opportunities to practice. Perhaps even going back to double or single digit subtraction. We'll explore what that looks like next. In our earlier example, we noticed when we broke down the task that a couple students struggled with single digit subtraction. Dr. Sarah Powell at the University of Texas at Austin demonstrates how to use manipulatives to further break down subtraction to solidify student understanding. Although this video illustrates the result is unknown in two problem structures, taking away and comparison, students may also use manipulatives to practice basic subtraction facts when a change or a difference is also unknown. A solid conceptual understanding of problem structure results in the ability to transfer knowledge of basic facts to other skills, such as word problem solving and computation fluency.
There are two concepts of subtraction that students should understand. The first is taking away. So I have a set of objects, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to take away from this set. I'm going to take away 3. 1, 2, 3. When I had 10 and I took away 3, I have 7 left. So that is the takeaway model. The other model of subtraction is understanding subtraction as comparison. So here I have my set of 10 objects, and I'm going to take away or compare that to a set with 3 objects. So when I compare 10 and 3, what is the difference between these two sets? The difference is 1, 2, 3, 4, 5, 6, 7. So 10 minus 3 is the same as 7.
In addition to what we've already learned, we're going to also talk about accommodations and modifications for students with disabilities, which are supports to help students access grade level content, but do not replace specially designed instruction. As defined by IDEA, accommodations reduce or eliminate the effects of a disability without decreasing the learning expectations. Modifications, on the other hand, are alterations to instruction and assessment that may change, lower, or reduce learning expectations. Some examples of accommodations include moving a student's seat closer to the front of the room, calling on a student frequently to keep them engaged in the learning, or highlighting keywords in a word problem. Accommodations do not change the material. They just provide a small support to help a particular student or group of students, and as we've learned, they can be used in tandem with other strategies. In fact, some accommodations may be implemented universally, like an assignment notebook. Modifications, on the other hand, should only be considered for students with disabilities that are significant in nature. Modifications could include teaching less or even a different content, including teaching standards content that isn't at their grade level. Remember, modification should be reserved for students who have significant needs, often for students with moderate to severe intellectual or severe learning disability with an IEP in place. What's most important to note is that modifications are supports to students that should not be used in isolation. We need to ensure that we've universally designed our instruction and further differentiated what we're doing for individual students before considering lowering our learning expectations by modifying our instruction or assessment. We've now walked through the concepts of universal design for learning, differentiation, scaffolding, and accommodations and modifications. But how can we make this a reality in our classroom? The content standards outline the skills and concepts students are expected to learn at each grade level. We need to know where these students came from and where they are going in order to know how to support them to get there. We also need to consider the standards for mathematical practice. If you're not familiar, check out the Features of Core Instruction modules for additional information. The next thing we need to consider when thinking about how to integrate the various strategies learned throughout this module into our classroom is our curriculum. We should take some time and review our curriculum, units, and/or lessons. For curricula, we'll want to see if it was reviewed by Ed Reports, and if so, how it rated. We should also consider if our curriculum, units, and/or lessons include, incorporate, and/or address all of the content and practice standards, if they follow the progression of skills over the course of the school year appropriately, and if there are any areas we need to supplement. That is, are there specific places that we need to go more in depth and/or take out? That is the curriculum covering non-relevant content? Essentially, the standards tell us what to teach, and curriculum is how we teach the standards. But what we know is there is no perfect curriculum. You may also have various instructional models in your classroom, instructional routines, small group work, workshop model, etc. in place. You should review the instructional models you are using because workshops or small group instruction in and of themselves are not synonymous with the concepts we discussed, UDL, differentiation, and scaffolds. They often provide a structure for teaching the curriculum, but could be universally designed or further differentiated or scaffolded to meet all students' needs. Now that we understand that we need to know where we've been and where we are going with students, and that there is no perfect curriculum, unit, lesson, or instructional model to teach our students, how do we get closer to perfect? Through the incorporation of all elements. This may sound daunting, but if done strategically, you can save yourself a lot of time and energy. Once we have reviewed our standards, curriculum, and instructional model, we can set goals for our learners to the content and practice standards. This could be done for each lesson using similar strategies across lessons over time as appropriate, or at the unit level. Then we can identify the methods we are using to teach our students and reflect on potential barriers students might face, such as language, their ability, unfamiliar vocab, or even concepts. From there, we will universally design our unit or lesson, considering ways to reduce the potential barriers through multiple means of engagement, representation, and expression, as well as thinking about students who may need further differentiated supports and/or accommodations or modifications to be successful. At this stage, we may be collaborating with other educators, including special educators, interventionists, or specialists, to ensure the strategies we've been using are based in the evidence and all students are supported based on their needs. From there, we will teach our lesson and evaluate its success. From this presentation today, we hope you walk away with the understanding that when planning, we should start with the end in mind. UDL, or Universal Design for Learning, can help us understand and address barriers that may exist. And finally, we can differentiate and scaffold what we universally design to meet the needs of all learners. Now, we would like you to pause and reflect. Think about your own instruction. What might you continue doing, and what might you consider making adjustments or adaptations to? Check out the resources folder for additional tools to support the areas you identified as needing adjustment. There's also an extension activity to complete should you choose. We'll explain that next. One of the best ways we can learn to improve our instruction is to provide feedback on others' instruction and then reflect on connections to our own instruction. In the module resources, we've included links to 2 different YouTube videos, one focused in a 3rd grade classroom, the other in middle school, pre-algebra to be specific. In the extension activity, what you'll do is first watch the video of the teacher's instruction. You may not need to watch the full video if selecting the middle school lesson. Just about 10 to 15 minutes is all you need. As you're watching, you should be thinking both about strengths, what does the teacher do well, how do you know, as well as areas for improvement. Specifically thinking about the concepts of universal design, differentiation, scaffolds, and accommodations and modifications. Are there any places where the teacher could add supports for all students or for some students? As always, thanks for joining. We'd like to take a minute and acknowledge the great team we have in place. The faces toward the right may be more familiar to those of you working in our partnering schools. The 2 on the left, Dr. Mary Little and Dr. Brad Witzel, helped develop some of the content for this module. We cannot thank them enough. And if you haven't checked out their book, Teaching Elementary Mathematics to Struggling Learners, we encourage you to do so. We also encourage you to check out the resources folder for additional tools, resources, extension activities to further your understanding. Thank you.